1 plus, and welcome back to this S.4 Mathematics. We are looking at application of differentiation to kinematics, and we are looking at calculation of velocity and acceleration. Example 5, which is the last example, part A, says the displacement s meters covered by a particle after time t seconds is defined by. So the displacement of a particle is given by t cube minus 6t squared plus 90 minus 4. This is the displacement of this particle at any time t. Roman 1 will guide us on what we shall do. Roman 1 says, calculate the velocity of this particle, which is described by a curve at the time 1.5 seconds. So the velocity when the time of the motion is 1.5 seconds. Okay, this is the curve. The motion of this particle is defined by a curve in a given manner. That is not our interest, but we can plot this curve. Now, for us to get the velocity at a given time t, 1.5 seconds, we need to get the expression for the velocity at any time t. What is velocity by definition? Velocity is the rate of change of displacement, that is ds dt. That means we need to get the gradient function of the displacement. Okay, the gradient function means the rate of change of that function. So ds dt means we need to differentiate the given function of the displacement, which is a curve. That gives us 3t squared minus 12t plus 9. We have differentiated it. This is the rate of change of displacement, which is the gradient function of displacement, and it is velocity. Therefore, the velocity at any time t is 3t squared minus 12t plus 9. This is the velocity of the curve at any time, or this is the rate of change of the curve, which is displacement in this case at any time. Now, what is the velocity when the time is 5 seconds? Yes, when the time t is 5, not 5 seconds, 1.5 seconds, 1.5 seconds. When the time is 1.5 seconds, what is the velocity? You come and substitute in the expression. Therefore, the velocity becomes 3 times the time. Time is 1.5 seconds squared plus, minus 12 times 1.5, and then plus 9. And then you simplify that on the calculator or by any means that you like. 1.5 squared times 3 minus 12 times 1.5 plus 9. I'm getting velocity as negative 2.25 meters per second. Let me check again. 12 times 1.5, 9 minus answer, plus 3 times 1.5 squared, negative 2.25. So this is the velocity of the curve when the time is 1.5 seconds. So that is for Roman 1. Going to Roman 2. Roman 2 says Roman 2 says determine the value of S, which is the displacement at the maximum turning point. Now, for us to get the value of S at the maximum turning point, let us first know what is the turning point of this curve that describes our motion. So part B, Roman 2, maximum, right? It is the value of S at maximum turning point. So let us first get the maximum turning point. What do we know? We know that at any turning point, dy dx is 0. That is generally. But for this case, at the turning point, ds dt is going to be 0. That is what we know. At any turning point, we have learned this. At any turning point, the gradient function of any curve is 0. So our curve in this case is ds dt equals to 0. That is at any turning point. Ds dt in this case is 0. That means the gradient is 0. Now, we need to get the values of time for which the gradient is 0 at the turning point. First of all, what is ds dt? ds dt is the rate of change of displacement, which is velocity given by 3t squared, because we know that ds dt is given as 3t squared, or we have obtained it as 3t squared minus 12t plus 9. That is the rate of change of displacement. This is the gradient function of the curve that describes our motion in this case. Now, what do we need to do? We need to first get the turning points. After getting the turning points, then we find the maximum turning point. After getting the maximum turning point, then we find the velocity, we find the value of the displacement at that point. So we equate this to 0. So 0 equals to 3t squared minus 12t plus 9. Okay? Then we solve this. This is a quadratic equation. Let me simplify by dividing through by 3. Gives me that. If I divide through by 3, I'll get that. And then you solve. Okay? You solve it by any method. Factorization, formula, completing squares, even plotting graphs. But don't waste your time plotting graphs. Or you can even use a calculator. I'm going to use a calculator to save our time. 1, -4, 3. If you want to know how to use a calculator, let me know and I will tell you. So, the first value of t, therefore the first value of t is 3, and the second value of t is 1. Okay, so these are the two values of t at the turning point. What does it mean? It means that we have two turning points. We have the turning point when t is 3 and the turning point when t is 1. Now, our question is asking at the maximum turning point. Now, of these two, when t is 3 and when t is 1, which one is the maximum turning point? We cannot tell right now. How do you test? How do you distinguish between the turning points of the curve? We say that for us to distinguish, let me partition this, to get the second derivative of the function or that motion. So we need to differentiate the gradient function of the curve or of the motion. And the function is given by ds dt equals to 3t squared minus 12t plus 9. This is the same as dy dx, where y is the function, which in this case is s, x is the variable, which is t in this case. So we find the second derivative, d squared s dt squared. In this case, this was the general expression, but our function is not y, our function is s. Our variable is not x, it is t. And then we differentiate this, it gives us 60 minus 12. This is the second derivative. Now, let us take, is the point when t is 3, is it minimum, maximum, or point of inflection? So we shall test when t is 3. See the nature of that point. Also, we shall test when t is 1 to know the nature of that point. In both cases, we are using the second derivative. This is the value of t. Substitute for t there. So that d squared s dt squared equals to 6. Our t is now 3 minus 12. And then we substitute. Then we simplify. It gives us 6 times 3. 6 times 3 minus 12. I'm getting positive 6. You see, I'm getting positive 6. What does it mean? It means that we say that if the value of the second derivative, let me use our expression, d squared s dt squared is positive. If it is positive, it means it is more than 0. We say it is minimum turning point. That means when t is 3, this is the minimum point. So when t equals to 3 is the minimum turning point. That means we shall not use this. Why? Our question talks about maximum turning point. That means now, by default, here we must get a maximum turning point. So, we're going to substitute again for t as 1 in the second derivative. That is d squared s dt squared equals to 6 times t, which is 1 minus 12. This here gives us negative 6. What did we say? We said that if the value of the second derivative, I know most of you are writing d squared y dx squared. Learn to change accordingly, equals to, if the value of the second derivative, negative 6, is less than 0, we say it is the maximum turning point. Therefore, it implies that t equals to 1 is the maximum turning point. Okay? So, if we look at our question here, it was asking for the value of x, it was asking for the value of s at the maximum turning point. So, if this is now the maximum turning point, then we say at maximum turning point, our t is 1. Now we're going to use this value of t, which is 1, okay, to find the value of s in this case. So we are given the function s equals to t cubed minus 6t squared plus 9t minus 4. But our t is 1. This here gives us now 1 power 3 minus 6. T is 1 squared plus 9. Our t is 1 minus 4. Let me press the calculator. 1 minus 6 plus 9 minus 4, 0. I'm getting 0 meters. Confirm. 1 cube is 1 minus 6 plus 9 minus 4. I'm getting 0. So at the maximum turning point, the value of s is 0 meters. So this is the solution to part A. In case you have questions, do not hesitate to reach out to us and we shall assign for you a tutor to guide you. Thank you.